let's go get this petroleum stuff. Okay, we're going to try to extract now. You should know that people often call this production or recovery. You should know that petroleum and gas are removed in phases. A little bit comes out on its own, a little bit you have to work for, and some of it you have to really work for. And the visual I want you to hold is a 5-gallon bucket full of coarse gravel with peanut butter and some bubbles working through that gravel. Okay? The production comes out in phases. There's the easy stuff, some harder stuff, and some really hard stuff. I'll explain. First is primary production, and that's easy. That's the easy stuff. That's old school. Basically, because you have all this rock on top of fluid, when you make a hole, some fluid will shoot out, like popping a zit. Sorry. You have a bunch of Earth's crust, and you drill a hole, and eventually when you hit that fluid, all of this weight wants to settle down on top of that fluid, and some of that stuff is going to come out. That's the easy stuff. It's called primary production. And you don't have to suck things out. That thing is not pulling up anything. When you drill a hole, the ground will settle a little bit and all of that gravel will find a more comfortable way to fit, and some of that peanut butter will get squeezed out of the hole. This gives you about 5, 10, 15% of the petroleum. And back in the day, this is where we would stop. Like in the earliest periods of petroleum extraction, this was the end. You make a hole, it shoots out of the ground, and like, okay, I guess we're done now. I would like everyone to please imagine that 5-gallon bucket of gravel with peanut butter is buried underground. Like 50 stories down at a minimum, but maybe 300, 600 stories down. That's really deep, y'all. How are you going to go get peanut butter out of crunchy gravel deep underground? You can't like suction. Everybody thinks that like somehow you're going to suck out the petroleum, but how would you do that? It's super thick and runny and it's full of sand, and that's a really long distance to run a pump. And by the way, it's in a rigid container. You know, like you could suck the water out of this thing because it's flexible, but if it's made out of glass, you can't suck the water out because it's a rigid container. The earth is a rigid container. So in secondary production, you start to do work. People call this enhanced production. This is like the first type of enhanced production. And now there's a lot of peanut butter left on those rocks, but instead of sucking out the peanut butter, you inject water, which will push through the gravel and squeeze out some peanut butter. This is a process of injection to add pressure so that the peanut butter gets chased out of a hole somewhere. You're pushing the oil toward the extraction point. And this is the most productive part of extraction. Somewhere around 20, 25% of the petroleum comes out this way. But now you got to do more work. Drilling holes, pretty efficient. Kind of like doubles your money in terms of energy. If you use 1 barrel to drill the hole, you get 2 barrels of petroleum out. That's pretty good. But here, you need like 3 barrels of petroleum to get 4 out. You know, in other words, you got to spend a lot of energy to pump water so that the peanut butter will get squeezed out. Here's a visual. You can see that there's injection happening. Those are the red arrows pushing downward. And then as that water moves through the porous rock, it's like pushing petroleum out of the hole. So there's one extraction well. And when you see this thing, usually it's injecting water. Most of those in an oil field are adding pressure. And then there will be one of them that's periodically opening a gate. So when it opens, it goes bloop, bloop, and that's not sucking the petroleum out. It's just letting the petroleum get squeezed out. So you've got a whole bunch of them adding pressure. And then somewhere in the oil field, there's one with a trap door that goes bloop and just lets all the stuff come out and surges. This is the majority of petroleum extraction. It's called secondary production. It's also a type of enhanced production. And it takes kind of a lot of work. There's a lot left. If you're doing the math, there's got to be a whole bunch of petroleum left underground. And so there's something else you can do that takes even more work. It's enhanced production because you got to really work for it. It's rarely worth it. If you follow my math, now you have to spend 5 barrels of energy to pull out 6. So the profit margin is getting really small. It takes a ton of energy to get a little bit that you can sell. You have a lot of debt with very little payoff. But you could get even more stuff off the gravel if instead of injecting water, you were injecting steam, because it's hot, right? And so that'll make the peanut butter runnier. So tertiary production, again, is enhanced production, meaning you have to do extra work to get the petroleum out. See, primary production is not enhanced because the petroleum comes out on its own. It's under pressure. But secondary and tertiary are both enhanced because now you have to add energy. Like I said, this is really cost effective. And here you have to find some way to get heat down there to make the oil runnier, make it less viscous, make it more fluid. And this will give you a little bit more petroleum. I've got an image coming up. Here we go. This shows you where you're injecting the steam that's becoming heated water underground that's probably going to push out a little bit more hot oil. And eventually, you know, when hot water comes out at the production site, then you're like, okay, well, might be time to kick back. Maybe we're done here. You let some petroleum come out on its own primary. Then you push some water through to get a bunch more out secondary. And then you push through some steam to see if you can wash those rocks a little better and get a little more petroleum out. That's called tertiary. And these are usually done in combination. So people don't make a well. People develop a field of petroleum. These are usually measured in square miles because sedimentary stuff is a layer. Right? So like a river mouth spilling out into an ocean basin will be like miles and miles and miles of a really thin layer. And then as you add more sediment and rock process, that'll get all convoluted. So over here it's easy and over there it's a little deeper. And usually you develop that whole field. This is a diagram of Little Rincon, what's it called? Arco Island. Arco Island, between Rincon and Little Rincon. Some of you have seen it's like a pile of rocks that has like a bridge that goes out to it. If you look really closely, it's got real palm trees, but also fake palm trees that are covering stuff up. So there's like a pattern of a palm tree, but when you drive by, you can see it's like, whoa, like it's a sheet of plywood that looks like a palm tree. Okay, Arco Island. That's Arco Island in the diagram. That's number 2 in this diagram. And so the rigs out on the continental shelf are usually injecting stuff. Then out at Arco Island, they're like processing some of the stuff. And way back on land, Like as you drive through, you're usually watching the ocean. But if you look the other way as you drive through, there's like a canyon. And if you look back there at night, you can see a whole bunch of lights. That's an oil field. I forget how many, but it's like 3.5 square miles or something. It's big. And back there is where the production happens. That's where the stuff is getting squeezed out. So pressure's being added offshore, and then the material is being produced or allowed out of the ground on land. And there's a mixture of additions of water, additions of steam, additions of CO2. There's all these plants that take the natural gas and burn that to heat the water that becomes the steam. It's really complicated, and these all work together. Before I move on, there's one last thing I need to emphasize. I don't know if you were doing the math, but 5 or 10% plus 15 or 20% plus 5 or 10%, there's a lot of stuff left. You know, how the heck would you wash all the peanut butter off all that gravel? That petroleum is sticky. Those rocks are deep underground. There's little pockets that are just not facing the right direction. So most of the petroleum is still down there. Usually we abandon an oil field at around the 60% mark. So we get about 40% of the petroleum, knowing that there's a whole bunch that we just can't reach. I mean, you could like use a long wire with a toothbrush and try to clean out a little bit of petroleum. So here's a crazy thought. There's always going to be more petroleum left. There's this fascinating conversation about peak oil that you should understand, not just politically, but in terms of environmental science. The idea that someday we're going to produce less petroleum, that will reach peak oil, that is kind of a complicated question, because peak oil would assume that you're running out, but there's so much left down there that you could say peak oil has already happened, and you could say that peak oil is happening now, and you could say that peak oil is way off in the future, and all three of those are accurate. I'll explain. See, the United States has a whole bunch of petroleum that we've already abandoned. A little bit that we've already produced. There's got to be some left that we don't know about. That's the blue. And there's like a little bit that we know about that we're still going after. That's the proved reserves. Let me see if I can show you what I mean. This we've abandoned. This we've gotten of the original petroleum in the United States. This we know is down there. This is the stuff that we're still going after. And then this is stuff that we haven't mapped yet. Some of it will have to leave, some of it we'll be able to get, but this is undiscovered. That's the remaining, statistically there must be some amount under the United States that we don't know about. But here's the point. Most of it, we already know that it's there, we just can't quite get to it. So if technology gets better, or if people pay you more, you'll be able to get that stuff. If a barrel of petroleum costs $1 billion, we'll just make a giant staircase and send workers down there to like polish every single bit of gravel, right? If it's worth enough. And so here's an interesting idea. Peak oil kind of already happened because we've run out of the stuff that's easy to get. Primary production was the main source of petroleum until about the 50s, 60s, 70s, when we just couldn't drill any more holes. It wouldn't come out on its own. So secondary production means we got going doing more work. And 70s, 80s, 90s, that was the majority of our petroleum production. We had to push water down to squeeze out some petroleum. And sometime around the early 2000s, that started to get difficult. And people were like, I don't know, man, there's just a lot of water coming out. I'm not getting any more petroleum. So sometime around the early 2000s, globally, we had a secondary production peak oil, and we just shifted to doing more heat injection. So now we're using more energy to get our petroleum. The energy cost of petroleum is going up. It's harder to heat water and make steam and push that around. You used to do 1 barrel of work to get another barrel that you could sell. Then we started doing 3 barrels of work to get the one that we could sell. Now we're kind of up to a standard in tertiary production where you have to use 5 barrels of energy equivalent to make 6. So you're paying back your debts. You're using 5 barrels to sell 1. So of course, that's going to raise the price, right? When you sell this one, it's got to cover the cost of those. And so peak oil probably will never happen. That's not the right way to think about this. But petroleum will get more difficult to find. There's still a lot down there. We're not running out. We're just running out of the easy stuff. Primary production peaked in the 50s, 60s, 70s. Secondary production peaked in the 2000s-ish. Tertiary production will probably peak sometime in your lifetime, maybe even in my lifetime. And then there'll still be plenty of petroleum. It's easy to get if you're willing to pay for it. What's interesting is when you leave it, it's kind of tough to go back. I don't know if any of you recognizes this image, but that's the mesa. I don't have the actual picture here. I used to lecture with this picture around. Sorry, I have the physical photograph of this because a family gave it to me because their grandfather was an oil baron in the Santa Barbara Mesa. So I'll see if I can explain. I think that this is Cliff Drive. And when you come down Flora Vista, is it? There's like that staggered stoplight that goes to like, is that Mesa Lane? I think that's Mesa Lane right there. So Mesa Lane, Cliff Drive, and Flora Vista. So there's a few houses here, and Monroe would be like off in this direction. There's Monroe School. And like now the Wilcox property, the Douglas Family Preserve, is off on the right over here. And there's like rows. Oops. There's like rows of eucalyptus trees along these roads, and this is like Schoolhouse Road or School Lane or something, and you go down Mesa Lane to the 1,000 Steps. That used to be an oil field. And at some point, people were like, well, this land has some real estate value. So yeah, we could keep like pushing water down, but that's not really worth it. We could just sell this land. And so at some point, you give up on the petroleum in the ground and you move on to another field. When you can drill anywhere, that keeps petroleum cheap because you're finding the easy to get stuff. So the argument today about peak oil is kind of dishonest. I think that the argument we should have is extremely profitable oil. No matter how much petroleum is left, every person who drills for petroleum is going to want a new place to drill. Because as soon as you drill the hole, you get the easy stuff. It's like popping the zip, come shooting out of the ground. You go, yeehaw! Then you catch it in your cowboy hat and you make some money. Primary is the easy stuff. But once you get down to the hard work, it's kind of like, I don't know, we're going to spend $1,000 to make $4. Like, that's just a lot of hassle for slim margins. And so there's a lot of fascinating market factors that play in. Once these places get developed, can you imagine if you had to buy all the houses on the mesa to get some petroleum out? Like, that petroleum is gone. It's buried now. It's buried under real estate values. Okay. Primary, secondary, tertiary, enhanced production. And the idea that there's a different amount of energy cost for each of these, 1 to 1, 3 to 1, 5 to 1. That's probably it for number 9. There's so many interesting politics to discuss, but I should probably stop.